derivative. So instead of subtracting from the power, we're going to add. And instead of multiplying by the power, we're going to divide. When we had an indefinite integral, we were required to put the plus c because the indefinite integral is actually trying to find a function of x. Now, the fundamental theorem of calculus tells us that this piece here, the integral from a to b, which is a definite integral, it's definite because we know the values of b and a, is actually finding an area. The fundamental theorem comes into play in that if we can find an antiderivative of the lowercase f, and it happens to be that the antiderivative is capital F, then we can substitute the values of b, the top value, and a, the bottom value, and it's f of b minus f of a. So some examples of how we would apply that. If we were to antiderive x squared, we would come up with x cubed divided by 3. Remember, we'll lose this notation because that's telling me that I need to do an antiderivative. Now that I've done the antiderivative, I don't need that notation, but I still want to indicate that I'm antideriving over the interval from 1 to 2. The fundamental theorem now says that I can substitute in. Personally, I like to hold my constants, like 1/3, and deal with them at the end, because it eliminates or reduces the amount of fractions I have to deal with. So if I have the 1/3 factored out, it'll still be applied to both the 2 cubed and the 1 cubed. I'm just going to do that at the end. So if I substitute in 2 cubed minus 1 cubed, I have 1/3 of 8 minus 1. So my final answer is 7/3. Similarly, if I antiderive 4, since I have no x's, I really have 1x now, divided by 1. I'm going to hold the constant 3. I have x cubed divided by 3. And instead of the plus c, I'm going to indicate that I have a definite integral. So we can simplify. So now the fundamental theorem says I substitute the top value in, which is 1. So 4 times 1 is 4. 1 cubed, since our 3's canceled, is just 1. Minus, if I substitute the bottom in, I get 0 plus 0. So my final answer is 5. For number 3, I'm going to go ahead and hold that 3/4 right from the very beginning. So you can think of it as just antideriving the x squared. So if I hold the 3/4, my antiderivative is x cubed divided by 3 from 1 to 3. Now again, I can simplify. So now I'm really finding 1/4. The x cubed gets the substitution of 3. So top minus bottom. On an FRQ, this would just be my answer. On a multiple choice, I would have to simplify this out. So 3 cubed is 27. 1 cubed is 1. So I end up with 26/4, which reduces because they're both factors of 2. So that would be my multiple choice answer. Okay, so continuing to practice. We antiderive x cubed to get x to the 4th over 4. -6, then we have x becomes x squared over 2. And instead of the plus c, we indicate our definite integral interval. So I can simplify. And now, I don't really have a common denominator, so it's going to be a little harder to factor out, but that's okay. Our top with parentheses, because we're doing top minus bottom. So we want to watch our parentheses notation. So if I substitute the bottom in, I simply get 0 minus 0. So 3 to the 4th is 81. 3 cubed is 27. Again, if this were a free response, this would have been my answer for the free response. Even if I had the minus zeros, still okay to leave them. For my multiple choice, I would have to find a common denominator. So I have 81 over 4. (108) over 4. So negative 27 over 4. So notice that this answer is a negative value. So that means that we've overall lost more than we gained. Doesn't mean that our curve was negative the whole time. It's an odd curve though, so part of it would have been below and part of it above the x-axis. And from 0 to 3, we apparently had more below than we had above. So for this next one, I'm going to rewrite x squared on the bottom is really x to the negative 2 before I antiderive. So I hold the 2, x to the 4th over 4 minus 6, x squared over 2 plus 3. And remember, I'm adding 1, so adding 1 makes negative 1 over negative 1 from 1 to 2. So if I simplify first, I have 1/2 x to the 4th minus 3x squared minus 3 over x from 1 to 2. Now for my free response answer, all that's required is that I substitute in the top minus the bottom. So 1/2 2 to the 4th minus 3 2 squared minus 3 over 2 is my top. I'm going to close off those parentheses. Minus, substituting 1 in, I have 1/2 minus 3 and minus 3 again. So that would be my free response answer. Simplifying for my multiple choice, I end up with 8 minus 12 minus 3/2 minus 1/2 minus 6. So this is when on a multiple choice those parentheses become very handy. So here I would say that I had a negative 4 and a negative 3/2. This minus sign has to distribute, so I end up with another negative half, but then a plus 6. So 6 minus 4 is 2. Negative 3/2 and negative 1/2 is negative 4/2. So I end up with 2 minus 2, which actually equals 0. So in this case, my odd powered function happened to match up so that the part from 1 to 2 completely canceled out. And we ended up with 0. For number 6, I'm going to simplify again before I start. So 2t squared divided by t squared is just 2. t squared root 2 divided by t squared is just root 2, which I'm going to write as t to the 1/2. And negative 1 over t squared is just negative t to the negative 2 dt. So when I integrate, I get 2t, t to the 3/2, because I'm adding 1, divided by 3/2, which is times 2/3. If you want to double check, if you multiplied this together, you would get 1t to the 1/2 for the derivative. Now going backwards, I have to add 1, so I get a negative 1 divided by negative 1. And instead of plus c, I indicate 1 to 9. So this would simplify out to be 2t plus 2/3, the square root of t cubed plus 1 over t, and it's still from 1 to 9. So doing our fundamental theorem, which is the top minus bottom, 2 times 9 is 18. I have 2/3. The square root of 9 is 3, which I still have to cube, plus 1 over 9. Minus, if I substitute 1 in, I get 2 plus 2/3 plus 1. So for the top part, simplified, 3 cubed divided by 3 is really 3 squared, which is 9 times 2. So I have 18 plus another 18 plus 1 over 9 minus 3 plus 2/3. Remember, this answer here, the very first one, would have been my free response answer. So I have 36 plus 1 over 9 minus 3 minus 2/3. So I have to distribute the negative. I'm going to write that 2/3 is 6 over 9. So I have 33 minus 5 over 9. So if I wanted to find this as a denominator of 9, I would have to multiply the 33 by 9 over 9. So now I have 297 over 9 minus 5 over 9. So 292 over 9. For number 7, I'm going to factor out the 2/3 constant. That leaves me with 1 over x squared, which I'll rewrite as x to the negative 2 dx. So I'm going to hold the 2/3. Antiderive x to the negative 2, I get negative 1 over negative 1 from 5 to 10. So I can factor out the constant and just have a negative 2/3, 1 over x from 5 to 10. So I have the negative 2/3 top, which is 1 over 10, minus bottom, which makes 1/5. So that's 1/10 minus 2/10. So again, this would have been my free response answer. So now I have negative 2/3 times negative 1 over 10. That's positive 2 over 30 or positive 1 over 15. And that's my multiple choice answer. On number 8, I can divide out to simplify. This is really x to the 1/3. So x divided by x to the 1/3 is x to the 2/3. I have a minus 2 with x to the negative 1/3 dx. So anti-deriving, I get x. When I add 1, I get 5/3. Dividing by 5/3 is multiplying by 3/5. Have a minus 2. Adding 1, I get a positive 2/3. Dividing by 2/3 is multiplying by 3/2. From 1 to 8. So I have 3/5. The cube root of 8 to the 5th minus 3, the cube root of 8 squared as my top part. And unfortunately for the bottom part, substituting in 1 always just gives me 1. So I just have 3/5 minus 3. And that's my free response answer. For multiple choice, the cube root of 8 is 2. 2 to the 5th is 32. Cube root of 8 is still 2. 2 squared is 4. 4 times 3 is 12. So I have a minus 3/5, and I can go ahead and distribute that negative to get a plus 3. So I have 96 over 5. I have a minus 12 and a plus 3, so minus 9, and a minus 3 over 5. So I have a 93 over 5, and I combine the fifths. I'm going to rewrite the 9 as negative 45 over 5. So I get 48 over 5 as my final answer. And now, the absolute value ones. I do not want you to try to do these as piecewise equations, although they are piecewise equations. This is really a piecewise equation that's 4 minus 2x if x is less than or equal to 2, and the opposite of 4 minus 2x if x is greater than 2. But you're not going to do the problem this way. You're going to do this problem graphically. You substitute 0 in, you get 4. You substitute 2 in, you get 0. You substitute 4 in, you also get 4. But if you substitute 5 in, which is our last value, you get 4 minus 10, so we end up with 6. Remember, a definite integral is asking for area. So the area we're looking for is the area from 0 to 2 plus from 2 to 5. So we can do geometry and get full credit on the AP exam for this question. So the first triangle, area is 1/2, the base length is 2, the height of this triangle is 4. The second triangle is 1/2, the base from 2 to 5 is a length of 3, and the height this time was 6, because that was the y value. On a free response, that would be my answer. On a multiple choice, I would get 4 plus 9 is 13. Okay, so as we continue, we're going to take the derivatives. using some different methods and using some different checks for AP problems. So, for example, we're finding the area under the parabola y equals x squared from 0 to 1. So graphically, what we're looking for is the y equals x squared graph from x equals 0 to x equals 1. So we're looking for an area that we can't find with regular geometry, at least not exactly. So when we see this, the area under the parabola, this is all a positive area, so that means that the integral will give me the exact area. So again, this is doing our base times height from x is 0 to x is 1. So we integrate, we get x cubed divided by 3 from 0 to 1. Using the fundamental theorem, I substitute in and I get 1 cubed is 1 divided by 3. 0 cubed is 0 divided by 3. 0 on top is just 0, not undefined. So the exact area is 1/3. Okay, similarly, we're looking for the area under the curve on the interval 1 to 4. So I'm going to simplify this out. 4x cubed divided by x squared is 4x. We have minus 7. X squared divided by x squared would just be 1. And then negative 3 divided by x squared is negative 3x to the negative 2. So on the interval 1 to 4, so what that means, we have to think about whether or not we actually get a positive or negative area. So if we were to use 1, we would get 4 minus 7 minus 3. So 4 minus 7 minus 3 is going to give us negative 6. If we were to use 2, for example, 8 minus 7 would be 1, minus 3/4. That would have ended up giving us a positive 1/4. If we were to use 3, 12 minus 7 is 5, and then we'd have minus 3/9. So 5 minus 1/3 is even more positive. So you can see that our function is going to continue in that upward direction, at least for this part. Okay, so if we were looking for this area, the integral isn't going to give us a strict area as far as a geometric area. What this is going to give us is a displacement, a total change in area. So we have 4x squared divided by 2 minus 7x minus 3x to the negative 1, because we're adding, remember. We can correct our notation a little here. So negative 1 divided by negative 1 from 1 to 4. So we're going to simplify. We have 2x squared minus 7x plus 3 over x from 1 to 4. We got a plus because the 2 minuses cancel. So substituting the 4 in, we get 16 times 2. So we have 32 minus 28 plus 3/4 for the top, minus, for the bottom we have 2 minus 7 plus 3. So that would be my FRQ answer. So I have 4 3/4 minus, this comes out to be 2 minus 7 plus 3 is a negative 2 overall. So minus a negative 2 makes a plus 2. So I have 6 3/4, but you tend not to see your AP exam questions written that way. It'd be written as 27/4. So they prefer improper fractions over mixed numbers. Okay. Now, this says, what is wrong with the following calculation? So it looks okay. We could write this as x to the negative 2. We could integrate x to the negative 2 as negative 1 over negative 1 from negative 1 to 3. That would then rewrite as 1 over x, but really be negative 1 over x. That's still okay. So we'd have negative 1/3 minus negative negative 1, so minus 1. Problem is, this is still all looks okay. Using the fundamental theorem of calculus, it looks right, but this is a completely inaccurate answer. I've come up with a negative displacement for 1 over x squared, and 1 over x squared is a strictly positive function. The problem with trying to do this using the fundamental theorem of calculus is we've tried to go from negative 1 to 3 across a vertical asymptote. So what we should have gotten was a positive area, or possibly a positive infinity area. So the fundamental theorem of calculus only applies if the function is continuous. So we can't use this method to integrate 1 over x squared unless we stick to values greater than 0 only, or values less than 0 only. Can't go across the asymptote. Okay, for this next one, if capital F and lowercase f are continuous functions such that capital F prime is equal to lowercase f for all values of x, then what would this area integrate to be? The easiest way to think of this is to substitute in. So we're doing the integral from a to b of capital F prime. Going backwards from a derivative gives us the original function back from a to b. And the fundamental theorem of calculus says we have to substitute in the top minus the bottom. So the correct answer is D. Similarly, f is continuous and has a continuous derivative. If the derivative is continuous, then f had to be continuous in order to have that derivative. So going backwards from f prime, we get f. Using our fundamental theorem, we substitute in top minus bottom. Okay, so this is not saying to take a derivative, it's saying that f has a derivative, which tells us continuity, which tells us that we can use the fundamental theorem of calculus. Okay, for this next one, if possible, we should always simplify before trying to take an antiderivative. We don't want to use a product or a quotient rule going backwards. So I'm going to simplify this out by factoring and canceling. So once I cancel, this is equivalent to taking the area under a line, x minus 1, from 1 to 2. But I do want to double check that continuity because technically we have a removable discontinuity. So we can't technically integrate across that. That's a whole using the fundamental theorem. The problem is the whole is at x plus 1 equal to 0. That denominator equal to 0, which means x would actually equal negative 1. We're okay. We're not trying to cross negative 1. We're going from 1 to 2. So we're okay that we're not using negative 1. So that whole happens to not be in our way. So now there's two ways I can integrate this. One way is using geometry. X minus 1 is this line. And doing the area from x is 1 to x is 2, we'll be finding the area of this triangle. And notice we're integrating x minus 1. So if I were to look at this curve, y equals x minus 1 is the curve. Then I'm finding the area under. At x equals 2, the y value would be 1. At x is 1, the y value is 0. I have a base of 1 and a height of 1, and this is just a triangle. So 1/2 base times height. The answer is 1/2. Since we were not trying to cross over the whole that's over here at negative 1, we could also use the fundamental theorem, which says we can integrate. We get x squared over 2 minus x from 1 to 2. So the top is 4 over 2 minus 2, minus the bottom, which is 1 over 2 minus 1, gives us 2 minus 2, which is 0, and 1/2 minus 1, which is negative 1/2. 0 minus negative 1/2 is positive 1/2. So we get the same answer either way. Okay, so for this next AP question, we have to do an integral, and this time k is any unknown constant. And when we do this integral, we're going to do the fundamental theorem of calculus and then set that result equal to 16. So if we anti-derive, we get x to the 8th divided by 8 plus k, which is a constant, times x. So remember, the derivative of this should equal what was inside the integral. So the derivative of a constant times x is just the constant. From negative 2 to 2. So if I substitute 2 in, I get 2 to the 8th over 8 plus 2k minus negative 2 to the 8th over 8 minus 2k. Now, a lot of students mess up this problem because of this second term right here. They failed to put the parentheses around the negative 2, and so they end up with the wrong answer. Negative 2 to the 8th power becomes positive 2 to the 8th power because it's an even power. It is not the same as negative 2 to the 8th. So what that means for us is that I end up with a positive 2 to the 8th over 8 plus 2k minus, now this term becomes positive 2 to the 8th over 8. When I distribute the negative, I get a negative of the positive. If I distribute the negative to the next term, I get another positive 2k. So these two terms, without me having to evaluate them, actually cancel. So I end up with 4k. So the integral is equal to 4k. I then set that equal to 16 to solve, and k equals 4. So then Notice I only set it equal to 16 because that's the value they gave me. Okay, so for this next part, it says to determine which of these is the greatest. Notice my starting point is at 1. So this is my starting point for all of these. I'm just going to figure out some areas from the graph here. If I were going from 1 to 1, from 1 to 1, doesn't really matter what graph I have. I have no base, so 0 base means 0. If I were going from 1 to 4, that would be finding this area. So the base is 3, the height is 2, the area of a triangle is 1/2 base times height. So 1/2, 3 times 2 is just an area of 3. So the area from 1 to 4 is equal to 3. Now if I want the area from 1 to 5, that would have to include from 1 all the way over to 5. So this has a height of 2, a base of 1. So again, 1/2 base times height, 1/2 1 times 2 is 1, but it's a loss, a negative 1. So now, going from 1 all the way over to 5, I gain 3, lose 1, I end up with 2. Now, a little bit trickier. If I want to do the area from 1 to negative 3, that starts at 1 and goes to negative 3. I'm going backwards. My smaller number should be on the bottom. But I wasn't asked for that. I was asked for 1 to negative 3. That means in order to flip this over, I have to put a negative in front. So I want the opposite value of whatever this area is here. So this is a 4 by 3. 1/2 4 by 3 is 6. It's a loss of 6. So if I were going in the forward direction, this part would be a loss of 6. But we're doing the opposite of that, so it actually comes out to be positive 6. Similarly, going backwards, I have a height of 3, a base of 1. 1/2 base times height makes this 3/2. But we are going backwards. So going backwards from 1 all the way to negative 4 means I'm gaining 6 and losing 3/2. So that makes this one 4.5. So the greatest value that I have is B. So if I'm going in reverse and undoing a loss of 6, that would be the largest value. Okay. Now, I put some notation here so that you'd be able to use your calculator. Just as a reminder of how you'll get to them. So on the TI-83, if you have the older calculator, you'll use the math button and number 9. You won't get this nice integral notation though. So you're going to have to enter it differently. Notice, for the old calculator, you'll get the fun_int, function integrand. You'll have to put your y1, whatever your function is here, comma x, so the comma's right here above the 7, comma a, comma b. So a to b. So it's your first value and then your second value. You're not doing the fundamental theorem. The calculator's doing a Riemann, and you're telling it where to start and where to stop. For the TID4, you can get to it with Math 8, but all of your calculus stuff is going to be fractions, the alpha button, and then you have 1, 2, 3, 4 things. Fractions are going to be very handier here. Function, and so your absolute values, sigmas, derivatives, integrals, and log bases are here. And then the other one you tend to use a lot is the y-bars. So we're going to go to our function, integrand, or you can do Math 9. So for this question, it says let big F be an antiderivative of this. So that's basically saying big F is the antiderivative of natural log of x cubed over x with respect to x. The x values that we want are 1 and 9. So that's going to give me the area from 1 to 9. So that means that we would get big F of x from 1 to 9, which makes this f of 9 minus f of 1. So that's just reading the sentence. Big F is an antiderivative of this function. So if we antiderive this function, we get big F. If we antiderive from 1 to 9, then we get big F from 1 to 9. The fundamental theorem says top minus bottom. I'm going to use my calculator to evaluate that. So from 1 to 9, I can do a fraction, parentheses. We have the natural log of x cubed divided by x with respect to x. So I have exactly this function, natural log of x in parentheses, cubed. I have to close the natural log, close the parentheses, cube the entire function on the top, and then divided by x, all inside my integral. And I came up with this value being, so this is equal to 5.827. Remember, I got my fraction by doing alpha y equals. Now that says that's equal to f of 9 minus f of 1. But f of 1 is 0. So I can substitute that in now. So that means that f of 9 is equal to 5.827. And the question says, what is f of 9? So we know it's just c. Now that was true because f of 1 happened to be 0. Okay, so very similarly, f is the antiderivative of this function. Simply means if I antiderive x squared over 1 plus x to the 5th with respect to x, I get little f of x, because little f is the antiderivative. I then see that I'm going to go from 1 to 4. So those are my x values. I use my calculator to evaluate. Notice I used my alpha F1, the first button, to give me the fraction to put inside here. I got my integral symbol by using Math 9, or on the TI-84 I can use alpha F2. I fill in the blanks on the 84 and get 0.376. So that tells me I get f of x from 1 to 4, which is f of 4 minus f of 1 using the fundamental theorem. So this integral is 0.376 is equal to f of 4 minus f of 1. So if I substitute in the 0, then I know that f of 4 is equal to 0.376. Okay, similarly, we have capital F of x is an antiderivative. So if I take the antiderivative of the square root of the function x cubed plus x plus 1 with respect to x, I get capital F of x. If I integrate from 1 to 4, that means I'm getting f of x with the fundamental theorem from 1 to 4. So that gives me f of 4 minus f of 1. Now if I use my calculator, I get 13.754 for this antiderivative. But this time, that's not the answer, because that's equal to f of 4 minus f of 1. But I have to substitute in, and f of 1 is minus 2.125. So minus and negative actually means plus. So I have to subtract 2.125 from both sides. So when I do that, I get 11.629 equals f of 4. So be sure that you're actually using the fundamental theorem in the top minus bottom. Okay, for this next part, the area under the curve cosine of x from k to pi over 2 is 0.1. The area under cosine of x from some unknown value to pi over 2 is equal to 0.1. The easiest way to do this is to take these values here and try them out. So I can do Math 9 or alpha F2. I'm going to start at 1.471. I'm going to stop at pi over 2. The function I'm evaluating is cosine of x with respect to x. I got an answer of 0.005. 0.005 is not the value that I want, so that's not the correct answer. I'm going to try another value. Notice I'm going to go up, I'm going to highlight this line, and press enter. I can then go back to the beginning and clear that one line and try the next value, 1.414. This time I got 0.012. Well, 0.012 is also not what I wanted. It's a little closer. I'm going to go back up, grab that again, press enter to copy it. Second left to go back to the beginning, and then I can move over and clear just that one spot. I don't want to clear the whole thing. And try 1.277. This time I got 0.043. Well, that's not correct either. So I'm going to try again. Copy, second left, move to highlight the part that I want to clear, and use 1.120. Now this time I got 0.099899558. So if I round that to one decimal place, I'm going to have 0.1. 0.099 rounds up to 0.1. But if I want to be sure, I can try the last term. Copy, go to the left, highlight, clear that one spot, 0.436, and I'm way off again. So this is the number that gets me the closest to 0.1. Okay, so this is basically the wording that says big F is the antiderivative of this function. So if we go from x is 1 to x is 2, that gives us f of x from 1 to 2. So if I use my calculator, the integral from 1 to 2 of the number 2 raised to the power x squared minus 2x plus 1 with respect to x, the integral comes out to be 1.288. Remember, we always do 3 decimal places, and that's equal to f of 2 minus f of 1. Now this tells me that f of 1 is equal to 2. So if I substitute in, I have f of 2 minus f of 1, which has a value of 2, equals 1.288. So now if I add 2 to both sides, I have that f of 2 is equal to 3.288. So that's the end of the fundamental theorem of calculus for actually computing the antiderivative. Next, we're going to view the fundamental theorem of calculus for canceling or taking the derivative of an integral.